Can ancient fungi tell us anything about climate change?
Does where you live impact on your health? What are some of the key factors to aging well?
We'll be exploring all this and more on this season of 10 Things to Know About.
This week, we're off to the coast to investigate the dynamic and inseparable links between our oceans and our climate. Stretching from the Arctic Circle to Antarctica, the Atlantic Ocean accounts for a fifth of the Earth's surface. It's Ireland's largest natural resource, and our history and heritage is defined by it. Living on the edge of the Atlantic Ocean has lots of benefits, but we know it can be a pretty wild and unforgiving environment sometimes. However, this intense setting is what allows some ecosystems to thrive. When we think of coral reefs, we tend to imagine turquoise seas and brightly coloured fish. But coral reefs can also be found in the cold, dark waters of the deep ocean. Erica Kruger has been studying cold water corals off the coast of Ireland.
I grew up in South Florida, and all I knew were the tropical coral reefs, full of color, sunshine, warm waters. And I didn't even know that cold water corals existed 4 years ago. So for some people, cold water corals are a very new thing, although we have been studying them for many years.
And tell me, what are they made of?
So they are made of carbonate skeletons. So cold water corals, when they feed, they will collect nutrients from the water column, so they need a very active environment to live in for the nutrients to be brought to them, and they will secrete this skeleton of carbonate, and that is what forms the base of corals.
So are they kind of like an exoskeleton?
They do have that hard carbonate skeleton that they grow, but inside of that actually lives an animal, and it's called a polyp. And so they're related to jellyfish and anemones. Cold water reefs can be found almost everywhere in the world's oceans. Some of my corals that I look at are from Norway, and some of them are from the Porcupine Bank Canyon and the Porcupine Sea Bite, which is in 500 to 1,500 meters water depth off of the west coast of Ireland.
Wow, they are deep.
They are, and they go deeper. In some places we can find them from 2,000 to even 4,000 meters water depth, where it's very cold, the sunlight doesn't reach that area, and so they thrive in these areas that are untouched by human hands. I actually have some if you'd like to see them.
I'd love to see some.
So this is a piece of Lophelia reef. They build these branches out, and all of these little holes and crevices in here are where all of those organisms will live.
So this is the result of hundreds of years of work.
Hundreds of years of feeding and making their habitat. So that is what we call a colonial coral, but we also have solitary corals where these polyps will grow on their own.
Wow, that's so different.
Yes, if you look at the inside of here, this is where this polyp will live, and you can see that's quite a large animal that lives in there compared to those which are much smaller.
Yeah, absolutely.
There are over 3,000 species of cold water corals, and in Irish waters, those two are some of the main corals.
Cold water corals are biodiversity hotspots that provide homes for more than 1,300 different species. But like many of our global ecosystems, they're increasingly at risk from changes to their environment. So what are the biggest threats to our reefs?
So deep sea mining, bottom water trawling from fishers, those kinds of things are what can be a detriment to these cold water coral communities on the seafloor, as well as we have energy resources that we are building in the oceans. And so we need to make sure that we're putting those in places where the corals won't be affected.
And like most ecosystems in the world, they're being affected by rising temperatures and climate change.
Yes. Coral reefs, we also are seeing that through rising seawater temperatures and ocean acidification. That is what my research is mainly focused on with cold water corals. So the ocean acts as a carbon sink, and it will absorb carbon dioxide from the atmosphere itself. But when the ocean gets too much carbon dioxide, it becomes acidified. And so what happens is the corals who use that water to grow their skeletons will become brittle, they will start to break off, and even when they grow, their skeletons might not be as strong.
Cold water corals exist at extreme depths, so studying them can be quite a challenge. Irish research vessels, such as the Celtic Explorer, contain remotely operated vehicles that can drop down to the seabed. They record videos and collect samples that help researchers to rebuild the history of coral communities.
Like tree rings, where we can get the information about the tree's history, we can also do the same with cold water corals. As they grow, they lay down bands, and we use those as geochemical records. So we can actually look at the elements that are in those bands, and we can recreate the past environment and the past climate of the ocean.
How far back can you see?
We have corals that we have dated back past 11,000 years. Some of the corals that I'm currently working with were alive from 600 to 7,000 years.
Wow.
And there are corals that have been dated even longer than that.
Wow, it's amazing, isn't it?
They are fascinating.
Fair play to corals.
One of the most important things is that I just want people to know that cold water corals exist, especially off the coast of Ireland. We have them right here where we live. But secondly, I think us being able to recreate the past climate history will help us to know what might come in the future. And so it will help us to determine these different areas of coral reefs where we might want to protect for the species that live there, or how we can prevent things from happening that will cause them detriment in the future.
It's so important to catalogue this, to know that they're there, to protect them in whatever way we can.
Of course, we can't protect something if we don't know that it actually exists.
Changes in the oceans have been observed since the first reliable sea surface measurements were taken in the late 1800s. But climate change presents an extreme challenge for the millions of creatures that live in the Atlantic and the people who live on its edges. Gerard McCarthy is an expert on how the Atlantic Ocean and the Gulfstream system of currents moderates our weather and climate.
So the Gulf Stream is something that is in probably the consciousness of every Irish person in terms of our climate. So the Gulf Stream, or equivalents of the Gulf Stream, exists in every ocean basin. So if we go to the North Pacific, we have the Kuroshio current flowing by Japan. If we go down to the South Atlantic, we've got the Brazil current flowing off the coast of Brazil. But what makes the Atlantic unique is that it's part of this wider system, which we sometimes call the Gulf Stream system, or scientifically we call it the Atlantic Meridional Overturning Circulation.
The Atlantic Meridional Overturning Circulation, or AMOC, is a large system of ocean currents that carry warm water from the South Atlantic northwards into the North Atlantic. As the warmer water arrives, colder, denser water sinks and begins moving south all the way to Antarctica.
So this process where we've got warm, shallow water coming northwards and cold, deep water going back to the south means that there's a lot of heat exchanged. Because of this extra heat that's released from the overturning circulation, the Gulf Stream system, that means that we've a climate that's about 5 degrees Celsius warmer than, say, similar maritime climates in the Pacific, such as Seattle.
For 2 decades, scientists have been monitoring changes in the Gulf Stream system, and recent research has raised serious concerns about the instability of this hugely influential system.
So the Gulf Stream itself will exist as long as the Earth turns and the wind blows. So that is not particularly at risk. But what is at risk is the wider Gulf Stream system, the overturning circulation. The whole world is warming up very rapidly. We know this from multiple lines of evidence. Now, it's a source of uncertainty what's happening in the North Atlantic. When we look through the whole 20th century, the North Atlantic is about the only place on the planet that's actually cooled. And we think that this is tied in with a slowdown in this overturning circulation. Understanding this problem is really critical because we are so dependent on the heat provided by this ocean conveyor belt that if it were to stop, we would really have an abrupt climate transition, which would be very difficult to manage. So under the most extreme scenario, we can expect slightly cooler temperatures relative to a background which is warming very rapidly. We can expect stormier winters, and we can also expect drier summers. And so drier summers is quite a problem for Ireland in the way that we manage our water supply. There have been studies that have looked at the effect of a complete collapse of the overturning circulation and have predicted that it would be the end of arable farming in Great Britain if it was to collapse completely.
The prospect of a potential end to arable farming would have a devastating impact on Ireland. There's a huge amount of research being conducted right across the Atlantic Ocean to better understand changes in ocean circulation and to develop measures to address it. In January 2023, Samantha Hallam was part of an Irish expedition aboard the Celtic Explorer.
It's been quite a challenging trip, actually. We did not have good weather. We've actually had storm after storm after storm. We've had fairly sleepless nights in our cabins as we've been bouncing around. The chairs have been going all over the place. This research is really important because what it really tells us is how the ocean is changing. This ocean climate cruise is something that happens annually for over a period of 15 years. And we go to the same stations. And when I say a station, what I mean there is the same point of longitude and latitude. So we take measurements through what we call the CTD. Deck, this is a dry lab. We're ready to take the CTD into the water. Please can you take it down to 10 metres. The CTD is a rosette with 24 Niskin bottles on it, and we lower the CTD from the winch into the water, and it takes measurements of temperature, salinity and depth and oxygen all the way as it goes down in the water column.
As the device is lowered to the sea floor, reaching depths of around 3,200 metres, Samantha is able to record and monitor the data it collects in real time.
So this shows us how the salinity is changing in the ocean. So you have a much higher salinity at the surface. Then we've got the oxygen profile, which is coming along here. Also have here the temperature, which is the red profile. And what we can see here is at around a depth of 3,200 metres, you've got a temperature close to 2 degrees, whereas at the surface, the temperature is much closer to 11 degrees.
As well as the real-time data, the bottles collect water samples at specific depths. When the device returns to the surface, each bottle is carefully labelled for further analysis.
We also measure the ocean currents in terms of velocity and direction, and that tells us how fast the ocean currents are moving northwards or southwards in their direction, and that's important so then we can use it on a comparison basis to compare to how it's been in previous years. The measurements that we are taking feed into our annual analysis of what's happening and the time series, so we can see year on year how things are changing.
As climate change continues to impact our planet, data that's collected on research trips will be essential to understanding and adapting to changes in our oceans.
The deep sea is home to many of the great mysteries of our planet. But off the Irish coast, the seabed has witnessed one of the most dramatic rescues in history. The incredible story of the Pisces 3 submersible and its two pilots, Roger Mallinson and Roger Chapman, is not one for the faint of heart. On the 29th of August 1973, the pair were laying telephone cables 150 miles off the Cork coast. While resurfacing to the mothership, a tow cable got caught and ripped the hatch off the aft sphere, a self-contained part of the sub. Instantly flooding and with the water alarm shrieking, the downward plunge began, the sub crash landing into the seabed at 500 meters water depth. Somehow still alive and intact, the crew knew an agonizing wait for rescue was ahead. With only 66 hours of oxygen remaining at normal working pace, to minimize their physical exertion, the crew lay down and did not even speak, the sub slowly filling with both carbon dioxide and silence. Every 40 minutes, they turned on a lithium hydroxide fan to scrub CO2 from the air and drip feed oxygen from their ever-dwindling supply. On the surface, a massive mobilization effort was underway, with crews sending down remotely operated vehicles. After 2 full days of failed attempts, a lift was initiated as inside the sub, the men slowly rose upwards to the surface. After 84 hours in darkness, the sub emerged into daylight with only 12 minutes of oxygen remaining. Resurfacing earlier this year during the Titan submarine implosion, the story of Pisces 3 remains the deepest successful rescue ever carried out, and one where every twist and turn was literally breathtaking. See you next time.
We know that the world's oceans play a key role in moderating our planet's climate. With a western coastline of approximately 2,600 kilometres, the dominant influence on Ireland's climate is the Atlantic Ocean. Enda O'D is a climate modeller in Met Éireann. And we live on this beautiful island with this enormous Atlantic coastline. How does that affect our weather and ultimately our climate?
The ocean effectively is like an enormous bathtub. It's a huge reservoir of heat, and that ameliorates the kind of extremes that we see on the continent. You can see very, very cold winters or very strong heat waves that we observe in the continent. We don't get that here because the ocean reduces those kind of impacts.
The ocean and the atmosphere interact on a massive scale, forming a complex coupled system where huge amounts of energy are exchanged at the ocean surface.
So it's a very complicated two-way system, and they're just only 2 components in the Earth system. There could be ice, glaciers, rivers, very, very complicated. And they become altogether as an Earth system model.
We're all familiar with the weather forecasts we see on the news every day. They're created by observing radar and satellite images and measuring data such as air and sea temperatures. Complex computer models are then used to accurately evolve those conditions forward to forecast the weather for the hours and days ahead. Climate modeling uses similar processes but with important differences.
Models for weather forecasting, it's about very specifics of what the weather's going to do in a very particular place at a very particular time. But there's a limitation on how far a weather forecast can go due to the chaotic nature of the Earth system. So anything beyond 10 days is basically impossible to get specifics about how the weather might be. Climate models are about the statistics of the future. They're about getting the averages, the means, the number of frost days you may expect in a typical winter, how likely a heat wave will be. It's all about probabilities, not specifics.
Researchers have been monitoring and studying changes in our climate for decades, and the annual average surface air temperature in Ireland has increased by approximately 1 degree Celsius over the last 120 years. Tito Semler is a climate modeller with Met Éireann. So Tito, what I'm looking at here is what we predicted 1 degree centigrade global warming would look like. How accurate was that model when we did reach 1%?
Yeah, so this is basically very accurate because, as you can easily see, is that the high latitudes, like here the Arctic region, has warmed more than the rest of the globe. We see that the tropical areas have been warming less, and the land areas more than the sea areas, because water is a big heat reservoir. And there is one little detail, which is here the region south of Greenland, that has even seen a slight cooling in the observations. And this is, of course, for us as scientists, very interesting.
This small blue area on the observed globe shows a decrease in temperature south of Greenland, which reflects the weakening Atlantic meridional overturning circulation. This regional disparity between the observed and simulated globes highlights the need to develop the research and improve models for the North Atlantic, which is of particular importance to Ireland and Western Europe. Tita, what are the climate projections for Ireland and the world?
So first of all, I should say these various projections are really a lot of work, and Paul Nolan of the Irish Centre of High-End Computing, iCHEC, has done all these simulations. Here we see 4 different projections. We see a very early action, mid-action, and late action. So depending on how we have our greenhouse gas emissions treated, that we can hopefully make an early action or even very early action. And what we can see here is how the temperature over the globe develops over time. We are now, for example, here end of the 2020s. The more we go on in time, the stronger the differences grow. And we see really very warm conditions in the late action scenario and reasonably not so much heated conditions in the very early action scenario.
Well, you really get a sense of the difference between if we start to do everything we can right now and doing nothing at all.
Oh yes, that's absolutely right.
And traditionally, we have talked about climate in terms of global terms. Is it possible to predict climate on a national or even regional level?
So traditionally, you're right. We've looked at fairly coarse resolution grids, maybe 100 kilometres by 100 kilometres. And it's necessary to look at the entire globe because the entire system is connected and interconnected. So a different strategy is this kind of a nested approach. And you could visualise that as a series of dolls, Russian dolls nested with each other, where we go to finer and finer resolution. So you might do regionally, say 12 kilometre resolution. And at national scale, you might go down to 4 or even less kilometre scale to really get into the nitty-gritty, the real details that matter locally to us. What's it going to be like behind a particular mountain or in a particular river system and so on. You will never get that in a 100 kilometre by 100 kilometre system.
As we continue to reel from increasingly frequent and extreme weather events, climate research is essential to help us adapt and plan for the future, feeding into flooding prevention measures, planning coastal erosion defences, and meeting the challenges faced by our farming and agricultural communities. That's our 10 things to know about the oceans and climate. Next time, we investigate how we can harness the power of our highly complex immune system.